Hello everyone, today we'll talk about the problem remove k digits. We are given a long integer represented as a string and also an integer k, which is the number of digits that we can erase from our number. And we want to erase them in such a way that the resulting integer is as small as possible. And so we have the examples. From this number we have to remove this digit, either of those two digits, right? So this is our allowance of 3, and this is the result. That's the smallest possible integer. Here we remove a 1, and we're being told that this 0 is removed for free. We only have to make sure we don't print it. And then we can, of course, get rid of the whole number in the last example case. If k was equal to 1, we could also just remove the 1 and the answer would be 0. This is one of those problems that requires an observation to solve. And I don't know if there's an easy way of coming up with this particular observation other than just thinking about it or looking at test cases and noticing a pattern. And the pattern here is that if you go through the digits of your number left to right, and whenever you encounter a digit you think about whether or not you have to remove some previous digits to create a better solution, then there is never a reason, right? It's never good to erase any previous digit that's smaller than the one you're currently looking at. And perhaps more importantly, what you want to do is, whenever you encounter a digit such as this 3 here, then if there are any moves remaining, then you want to remove this 4 because it's greater. So now the first two digits are not 1, 4, but 1, 3, and that's better than 1, 4. And of course you don't want to remove the 1 because the 1 is smaller. Same here. You look at the 2, you still can erase a digit, so you erase this 3 here. Right? So you want to erase digits that come before you if they are greater than you. You don't want to do that if they are smaller than you, if the previous digit that's not yet been erased. And it turns out that by following this strategy, we can indeed make sure that the number that we get is the smallest possible one. So if we come up with this observation, then solving this problem becomes quite easy. Let's see the code. We're going to just be maintaining our current number as it's being created. We'll put our incoming digits into this number. However, as long as we have some moves remaining and the last number in our result being constructed, last digit, is greater than our current digit, then it's always good to remove that digit. And of course we use up a single move by doing that. And then if we implement it like that, we also have to make sure that if we go to the end of the string, the digits are non-decreasing, and we still have some moves remaining, then we can still make those moves. And to make those moves, we want to essentially remove the digits from the right, and they're going to be the biggest digits, so that's also quite easy to see that it will be the best solution. So if we have any moves remaining after the end, we just get rid of digits from the right. So that's this part. And then we have to skip all the leading zeros. So that's this part. If there is nothing remaining, then the answer is 0. That's the only way an answer can have a leading 0, if it's just 0. Otherwise, it's just all the digits skipping those leading zeros.